These next two videos are going to be looking at how interrupts actually happen, the principles of operation. So, let's imagine we've got a device like a keyboard. Blah, 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 blah. Now, what will happen is you press a key on a keyboard and it sends a signal, beep, 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 or one, to the operating system. Now, you should know that what an operating system is, like Microsoft Windows or Apple iOS. So it sends it to the operating system, a signal. It's like basically saying, hey, 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 I need your attention. I need your attention. I need your attention. I need your attention. That's what happens here at this bit. Now, the operating system and the processor are literally always ready to handle interrupts. They're like always on alert, always on edge, always wondering when the next interrupt is going to happen. Each interrupt, so let's say a user input or input output or hardware fault or program error, each one, so let's just do program error, let's do input output request, let's do user interaction. Each interrupt basically is treated differently. So let's imagine that this dude has a name badge. Hi, my name is program error. Hi, my name is, you must have seen these little name badges before, IOReg, etc. So literally, the processor must identify, so this dude here, the CPU, must identify what the interrupt is, the type of interrupt. Once it's done that and it's identified the type of interrupt, the processor will put it into a register. What do you think the register is going to be called? You got it. The interrupt register. Now, after this, so let's just go through the steps again. Device sends a signal to the operating system. The operating system, well, requesting its attention. The operating system and the processor are always expecting to be interrupted, so this isn't a problem. The processor will identify what type of interrupt it is. It'll give it an ID, like these. It will then pass it on to the interrupt register. At the same time, the processor basically stores what's already in the fetch, decode, execute cycle into memory. So let me just say that again. Whilst it puts it into the interrupt register, the processor also stores whatever's inside the fetch, decode, execute cycle in its registers into memory, so that it can return to it later on once they've dealt with the interrupt. So remember, you've got your fetch, decode, execute. You've got your interrupt. Hello, not. The CPU is like, okay, coming in. After you've done your execute, I want you guys to stop. So you don't forget what you're doing, I'm going to put it into memory for you. Let's deal with the interrupt. You guys do your spiel. Excellent. You guys are done. Let's bring back the data, the information, the instructions back into the registers again. This basically allows programs to be interrupted and left in a state so that they could be returned to later on. I'm hoping that makes sense. So try and list that into order, starting with this one here and ending up over here. Or shall I say, down here. Once you think you've mastered it, you can move on.